Hi, so let's move on and we talk about the next module. We will talk about the measures of central tendency and the measures of variation. In the previous module, we already learned that the data should be divided based on whether it's a quantitative data or a qualitative data. And based on that, we are going to find out whether it's a nominal, ordinal, interval or ratio data. So let's get going and let's move slightly deeper into this understanding. Let us say I have two populations with different TSH levels. Let us say this is the TSH levels of the population, population A and population B. I want to find out that which population is having slightly higher TSH levels or what percentage is having higher TSH levels in either of the population A or B. So you're technically trying to compare the populations. So if you are technically kind of comparing the populations, what is the most basic thing or what comes to your mind at the first level? Don't you think what you're saying is that let me just add on these people, you take first, second, third, and you add them, right? What is the symbol for? This is a sigma. It stands for summation, right? It stands for summation. So this is a sigma. You summate everything, divide by the n. N stands for the sample size. So this is the first measure that you're going to do. What technically are you doing? This is what we call it as the mean. What is mean going to tell you? That you take all this data together and you find the center point. So that means when you want to compare data, you will find the center point of the data. That brings you to understanding of the first topic of this chapter, that you are going to learn about the measures of central tendency. What do you mean by the measures of central tendency? You're going to calculate what? We will talk about the mean, the median, and the mode. What do you mean by the mean, median, and the mode? So let's talk about the first thing, that is the mean. Mean can basically be classified into three types. We can have three different types of mean. We can have an arithmetic mean. We can also have a geometric mean, or we can also have a harmonic mean. What do you mean by all this? The arithmetic mean is simple average, what we all calculate every day. That is what is arithmetic mean. It is given by a formula, simple formula, summation over the sample size, that is the n. What do you mean by geometric mean? Geometric mean is calculated in case of, ICO stands for in case of. Geometric mean will be calculated in case of exponential data, or in case of data with extreme values. Very soon you'll understand when I give you examples, you will understand. But right now, just remember that geometric mean is for exponential data or bigger data or data with extreme values. Harmonic mean, on the other hand, is calculated in case of. When will you preferentially calculate the harmonic mean? It is calculated in case of inverse data or when the data is in fractional numbers. Please also remember that mean, some of the important MCQs over here. Please also remember that what are the advantages of mean. The mean is the best measure of central tendency. Mean is the best measure of central tendency and it is the easiest to calculate. In fact, it is one of the first things that you are going to calculate, and you also did that. When I asked you how to compare the population A and the population B, what you did was you calculated the mean. So that is what is the measures of central tendency. What is the disadvantage with mean? Why under certain situations we use the median or the mode? The disadvantage of mean that you can remember is that it is most affected by extreme values. It is one of the entity which is most affected by extreme values. So can you please highlight that it is most affected by extreme values? It is one of the best measure. The next is that you can learn is what is the median. What is median? Median is the central value after arranging in ascending or descending order. After arranging in ascending or descending order, very important that it is the central value only after you arrange in ascending descending order. So example for median is, when will you calculate median? Like, why would you use a median? The advantage of median is, please remember, it is least affected by extreme values. It is least affected by extreme values. Can you please highlight the word it is least affected by extreme values? No disadvantage of median, but if I give you an option that either you calculate mean or the median, which one would you prefer for a normal distributed data or a normal data? You would prefer mean. Mean is one of the best measures of central tendency, and but the disadvantage is it is most affected. That is what is the advantage of median, that it is least affected by extreme values. Don't get confused on this. Next is, what is mode? Mode means the most frequently occurring value. Mode is, many of you must already be knowing this, not very big rocket science till now. It is the most frequently occurring value. It is the most frequently occurring value. So do you need to arrange it? Of course, there's no need of arranging it. What is the advantage of mode? The advantage, that why do we use a mode, is that it is the most robust measure. It is the most robust measure of the central tendency, and again it is usually last to be affected with extreme values. It is also least affected or last to be affected with extreme values. But mind you, out of median and mode, which one is a better method of central tendency? It will be the median. So last to be affected with extreme values. So mode also is a robust measure. Can you please highlight what is, can you please highlight that mode is the robust measure? So what you have done till now is you have learned that there is a median, there is a mode, and there is a mean. That is what you have done, and I helped you highlight some of the words. Let me go ahead now and I give you an example, right? Let us say that I talk of an example that, let us say there is a data type like 3, 5, 6. Okay, I've written 5 and 6 and 3 and 4 and 2 and so on, many things. So how many numbers do I see? 1, 2, 3, 4, 5, 6, 7. That's fine. So in this data, what are you going to calculate? The mean or the median or the mode? Perfect answer is I'm going to calculate the mean. Okay. Next, let us say I change the numbers. I take the number to 5 is replaced with 6,842. So you have the data 6,842, 5, 6, 3, 4, 2. In this section, what are you going to calculate in this scenario? I think your best answer should be a median. Why median? Because don't you think that if the mean is, I'm going to calculate in this, the mean will technically be pulled towards the 6842. Why? Because the mean is most affected with the extreme values. The best answer should be a median. So that is example 1, example 2. So now let us take this third example. I need to rewrite this whole thing. Let us say this is 3 and 5 and 5 and 6 and 3 and 4 and 2. It's the same data I've just rewritten. You want to calculate the median, for example. To calculate the median, you need to rearrange the data. You remember median, you had to put them in ascending or descending order. So let's try putting them in ascending, descending order. You write it as 3 and 3 and another 3 and 4 and 5 and another 5 and 6. So that is your total data, 3 and 3, 6 and 1, 7. So that's your total data. Now calculate the median. Median will be this side, and so the median is the 4. Okay. Now let us say in the same data, now let us say maybe 3 is replaced with 7. So now your data, can you beat that? Your data will be 3, 2 and 3 and 4 and 5 and 5 and 6 and 7. So what is the median now? The median has changed. Are you getting it? With the slight change in one data, the median changes. It is least to be affected by extreme values, but it is affected with the change in data. Mean will also change if I replace 3 with 7. Mean will also change. So that means with changing data, both mean and the median will change. Which is not going to change, that is the mode. Mode is the robust measure. Mode is the most robust measure. It is like a pillar. Are you understanding that data with extreme values? What are you going to mark in your exam? Many times students get confused just on a very simple phenomena. Try understanding, bache. Take it easy that when we ask you, which of the following is the best measure for extreme values? Your answer should be median. But if I ask you that which of the following type of mean will you calculate for data with extreme values, in case I am stuck on this idea that I have a data with extreme values, what is the mean you're going to calculate? Then please answer geometric mean. Are we okay with this? So these are a couple of confusing things. Next, sometimes we give you a data, that data is changing all the time. What is the best measure? Best measure would be mode. But data with different values or extreme values can happen next. After mean, the next best answer is median always, when the data is with extreme values. Are we getting it? So please remember that data with extreme values, the answer should be mode. In case we ask you data with extreme values in mean, what is the best answer? It should be a geometric mean. Please also remember that mode can be calculated by a formula 3 median minus 2 mean. So sometimes in your MCQ exam, we'll give you a value for mean, we'll give you a value for median, and we'll ask you to calculate the mode. So that's how you're supposed to calculate a mean, median, or the mode. Also, please remember an example for geometric mean is very frequently asked in your exam. Geometric mean, one of the favorite MCQs from examiner is geometric mean example is the Human Development Index. You remember that in Human Development Index, we had a life expectancy index, we have a knowledge index, and we have an income index. All these indices are taken together, and for all these indices, we calculate the geometric mean and then come up with a number. So that number for India is 0.647, and India stands at a rank of 129 for the HDI. So that is as per the 2019 and 2020 data. But it may change all the time. But the point over here I want to bring out over here is that geometric mean is used in many situations, specifically talking is HDI. So now after understanding the mean, median, mode, let us try to implement that. Let us say there were two populations, population A and B, and we calculated the pain scores, mean pain scores in each of the population. The lowest was 0 and the maximum which could happen was 15 or 20 or whatever number. I want to find out pain was more in A or in population B. So how are you going to find out? You calculate the summation and divide by the sample size, you're going to calculate the mean. Let us say that the mean in B was more than mean in the A. Mean is always given by the symbol X bar, okay? So please remember that X with a bar on the top will be the symbol for mean. So let us say mean in B was more than mean in A. So that technically means that the pain was more in group A. Simple. But by chance, let us say that the mean in both the groups was same. That is, the mean in B was equal to 6 and the mean in A was also equal to 6. Now you are in a big soup. Can you say that population B experienced the same pain levels as population A, where you see that the pain was slightly more in category B patients? So we don't know that, how to ascertain that. So what you're forgetting is that even if the mean is same, there is a chance that population A is there which had the lowest number as 4 and the highest number as 10, and the mean you could see was 6. And there could be a population B which had the lowest number as 1 and the maximum, let us say, was 11 and the mean was again 6. You are seeing technically the center portion, but you are not seeing the range or the bigness of the data. So you have to see that what is the range or the bigness of the data. That understanding will bring you to the next module or the next chapter we are going to talk about is the measures of variation. So once you talk of the quantity or the quality data, you check for the scale of data. Once you're done with the scale, you check for the measures for central tendency. And once you're done with the central tendency, now you're going to check for the measures of variation. Let's go ahead and let's see what are the MCQs you need to remember for measures of variation. If you talk about the measures of variation, the first measure for variation is called as the range. Not very frequently used, but that is the most basic thing. Range is nothing but the maximum minus the minimum. It tells you the range of the data, nothing very special. The second measure of variation that you need to study is something called as standard deviation. What do you mean by standard deviation? What is the standard deviation? Simple. Let's see a population. Let us say that in this classroom, there is a student who sits in the center of the class. And there are 4 more people in this class. So what is the range of the classroom or the student sitting in this class? The range would be like this point, this point, and the center point is this. Simple. Let us say that the classroom is slightly different. The same size, everything same. Now there are a couple of students who are sitting in this class. Many students are sitting in this class. So again, the mean will be the same. Are you getting it? The range will also be the same as in classroom A and classroom B. The range is same, the center point is same, but the values have changed. Let us take another scenario. Let us take another classroom. The same range is there. In this, the maximum students were sitting here. One student was in the middle and other maximum students were sitting here. And 1 or 2 students were sitting on the other sides. So now again, where is the mean? The mean will again be in the center. What is the range? The range is still the same, but the location of populations or the location of values in space, they have changed. So this understanding, that mean I understand is a very good thing. That is the central point. The variation, the range and understanding is also very important. But you should see how the values are located in space. For that, you should find out what? You should find out, listen carefully, you should find out the mean deviation of every value from the mean. That concept of understanding the mean deviation of every value from the mean is known as the standard deviation. Are we getting it? So MCQs on standard deviation. The standard deviation, first MCQ, is given by the formula. What is the formula for standard deviation? It is root mean square deviation. It is root of mean of squared deviations. Squared deviations. Will you remember this for me? It is a root mean square deviation, root of mean or squared deviations. It is given by this formula. Square root of mean. Mean means summation by n. Square root of mean of squared deviations. Squared deviations. Deviation from the mean, which is squared. So it is given by this formula, square root of mean of squared deviation. That means there are 3 components. It is the square root of, it is the mean of squared deviations. Are you getting this point? There are 3 components of this formula. Square root mean deviation, RMSD, root of mean or squared deviations. So this is what you need to remember for your MCQ exam. In your real exam, if you don't remember this by heart, in your real exam, we might give you a scenario like this that you're seeing on the screen. So you can tick off option A, B, C or D. So in your real exam under anxiety states, there is chance of getting a wrong answer. Please mind it that you have to remember what? Root mean square deviation, that it is full square root of summation of mean square deviations divided by the sample size, by the n. So another variant of this formula is n minus 1. So what is this n minus 1? N stands for the sample size, you already know. So n minus 1 is a correction that we use. N minus 1 is a small correction we use for small sample. So that means the formula for standard deviation is standard, that is root mean square deviation. But with n minus 1, whenever the sample size given is very small. What do you mean by small sample? N will be less than 30. So in case of n less than 30, the formula becomes divided by n minus 1. So now once you have learned this formula, now let us try to practically use this formula and let's try to imbibe that into the gray matter. If you understand it practically, that is going to help you to put that standard deviation formula into the long-term memory or the gray matter. Let's use the same example that we used before and let us say that the mean over here is 6. So what is the concept of standard deviation that you learned? You learned that standard deviation is something which tells you about the mean deviations from the mean. Right? That's what is standard deviation. So you take one value. Let us say we take the first value. We have to see how much it deviates from the mean. That is what is standard deviation. It is the mean deviations from the mean. So how much is 4 deviating from 6? It is 2. Wrong answer. It is minus 2. 1 will be deviating how much? 1 is minus 5. 6 will be deviating as 0. 9 will be equal to 9. How much it deviates? Plus 3. And so on and so forth. So now you add them. That is what this is the formula. You remember summation x minus x bar whole square divided by n. Then you do under root. So that means you should add them. Answer is no. We are not supposed to add them right away. Why? Because what is minus 2 and add plus minus 5? then 0, then plus 3, then whatever, don't you think the answer will be 0? Why? Because from a center point, you are saying how many are less and how many are more, and the center point is the center point. So answer has to be minus and plus will be 0. So how to remove these signs? What you remember from your mathematics is how to remove these signs. You square them up. X. So what you do is x minus x bar whole square. That is what you do. So what is 2 times 2? That is 4. So this comes out to be 25. This is 0. This is 9 and so on and so forth. And now you add them. And now you divide by the sample size. So summation of this numbers, summation of the squared numbers divided by the sample size, and because you squared them, you do the under root. That formula or that concept is going to tell you how much is the mean deviation. That funda is called as the standard deviation. So what you have done till now is you have talked about the measures of variation, where you have talked about the range and you have talked about the standard deviation. Now let us move forward and talk about the next point, that what is a variance. The formula for variance is very tough. Do you know that the variance formula is given by SD square? So first is in standard deviation, you learned about the root mean square deviation, and in variance, it is the square of the SD. That means the root thing is gone. So what is the formula for variance? Variance is given by the formula summation x minus x bar whole square divided by n. That's it. This is the formula for variance. It is given by a symbol capital V. There is something else to this. You can also learn something called as the coefficient of variation. What do you mean by the coefficient of variation? Coefficient of variation is given by the symbol CV. It is, what is the use of coefficient of variation? It tells you about the absolute variation between two different populations, and that was your MCQ in one of the AIIMS exam just recently as well. How do you calculate the coefficient of variation? The coefficient of variation is calculated by the formula. It is the standard deviation of whatever the population is divided by the mean multiplied by 100. So with that, you will calculate the coefficient of variation for population 1, and on the same basis you calculate for the population 2, and then you are going to compare. So basically it helps you compare in terms of adjusting for the mean and the standard deviation. Please remember, what is coefficient of variation? It is absolute variation between the two populations, and the formula is given by standard deviation over mean. So what you have done till now is you have talked about these 4 points in measures of variation. Let us come to one of the 5th point. Now we need to talk of something called as standard error. Now what is this standard error? It's a standardized error. What do you mean by standard error? There are 2 concepts of understanding. The example number 1, let us say I take this is the population. You come and do testing for the mean hemoglobin levels. You find this is the mean and this is the standard deviation. Your friend comes, he also does or she also does. So they find their mean and their own standard deviation. I come, I check the mean and own standard deviation. Now the mean of all the means, there will be a lot of means. The mean of all the means is called as the main population mean. It is a lot of means will be there. So these means is called as the population mean. And the mean of the standard deviations, mark the words, the mean of the standard deviation. This is going to be standard deviation 1. This will be standard deviation 2. This will be the standard deviation from the 3rd study. So the mean of the standard deviations, how on earth would you calculate that? The mean of the population mean and the mean of the means is called as population mean, and the mean of standard deviation is called as the standard error. That is what this concept is. It's a beautiful thing to understand that the mean, you can all take all the means, you can add them, divide by the sample size, you will find the population mean given by the symbol mu. It's given by the symbol mu. And the standard deviations, how to find out the central standard deviation? The concept is that it is the standard error. So standard error basically tells you the error in different studies in terms of the standard deviation. So next is another way to look at is, let us take another example. Let us say this is our country. So one of my student down from south from Tamil Nadu, they gave me the mean blood glucose. Mind the language. They gave me the mean of the blood glucose. plus minus their standard deviation. One of my another close friend from Hyderabad, they gave me the mean and the standard deviation. I got it again from Manipur, the mean and the standard deviation. Also from Delhi, we got the mean standard deviation. Again from Rajasthan, we got from Gujarat, Maharashtra, so on. So that means you can take the mean 1 plus mean number 2 plus mean number 3 and so on, divide by the sample size. That will give me the population mean. Will that give me the population mean? Simple answer. But everyone had its own standard deviation. Now, the standard deviation 1 plus standard deviation 2 plus 3 divided by n does not work here. The concept is how to find out the mean standard deviation. That is found out by the standard errors. So what in simple technical terms standard errors? It tells you the errors you will achieve, or it tells you the deviation between the values when different researches are there. Anyways, in your exam, nobody is going to ask you why do you do standard deviation, standard errors, but they can ask you how to calculate standard errors. That is what is required for your exam. Standard errors can be directly calculated by two forms. We can have standard error for mean or standard error for proportion. Standard error for the mean or standard error for the proportions. You remember in your previous module, you discussed about the quantitative data or the qualitative data. In quantitative data, we calculate the mean. So for quantitative data, you're going to calculate the SEM or the standard error for mean. For qualitative data, you're going to calculate the SEP or the standard error for proportions. The formula for calculating standard error for mean is given by the formula SD over square root n. SD over square root n, and the formula for calculating standard error for proportion is given by PQ over n whole under root. Can you please remember this formula? This is SD by square root n, and SEP is given by the formula PQ by n whole under root. What is a P over here? P stands for the prevalence of the data. Why? Because it's a qualitative data, right? The prevalence. Q is 100 minus prevalence. N stands for the sample size. Right? Over here, SD is SD, N stands for the sample size. Right? So this is how you calculate the formulas for standard error for mean and standard error for proportion. A small trick for you to remember in your exam. Please remember that whenever a question will be coming on, either p-values are given, or if the confidence interval is given to you, in those cases, you should use standard errors and not standard deviation. I don't know how to lay stress on this, but this is the most common mistake students do. In your exam, I'm telling you a small trick. Please remember it, write it in bold letters in your copies, that whenever in the exam p-values or the confidence interval will be given, do not do this mistake of finding out the standard deviations. Use standard errors or calculate the standard errors. How to calculate standard errors? The standard deviation will be given divided by the square root n, that is the SEM, or the prevalence into Q, that is 100 minus prevalence divided by n whole under root is what is SEP, and that is what is SEM, right? So with that, you have covered this module on measures of central tendency and measures of variation.